Good evening, children. In today's lesson, I'm going to teach you under chapter 8, which is on electricity. First of all, we need to discuss about the types of current. There are two main types of current. One is a direct current, which we call the DC current. The current which remains constant with time is called the direct current. That means direct current does not change its magnitude nor polarity. Okay, it comes with constant magnitude and polarity. The cell or the battery provides us the direct current. So these are the sources for direct current. Then we have alternating current or AC. The current which changes the magnitude and polarity with time is called alternating current. Okay, usually in alternating current we have 50 on the positive side and 50 on the negative side, that is in total 100 in 1 second. Okay, the mains is the source that we get from the electric supply of this city substation, and AC generator provide us with alternating current. So these are the two sources which give us mainly with alternating current. Electric current, the rate of flow of charge, okay, charge with symbol capital Q, or we can also define it as flow of charge in unit time, is called electric current. The symbol of electric current is capital I. Its SI unit is ampere, symbol is capital A. So I is equal to Q by T. Alright, that is what we mean by the rate of flow of charge. So from here, this first equation we mark it as equation 1, and from here by cross multiplication we get Q is equal to IT. We mark it as equation 2, where Q is the charge and T is the time. Okay. Now the next is potential difference. The work done in moving a unit charge from one electrode to another electrode is called potential difference. Okay, you see in a cell or a battery, usually it's the electrons that move on their own. Okay, but if we want to move a unit positive charge, then work will have to be done. So to move a unit positive charge from one electrode to another, that is known as the potential difference. Its symbol is V, capital V, and its SI unit is volt with the symbol capital V. So both are having the units of V, the symbol of V. Okay. Then electrical power. The rate of supply of electrical energy is called electrical power. The symbol of electrical power is P. Its SI unit is watt with symbol capital W, but if you write it in full, it's all small letters. Okay. Therefore, we have P equals W by T. Okay, because it's the rate of supply of electrical energy. All right. Then the next is electrical energy. The capacity of the source to supply the current is called the electrical energy of the source. Okay, and its symbol is W. Okay, so electrical energy has the same symbol as work done. Okay, W. And its SI unit is joule. Remember, energy has SI unit of joule. Then electrical energy and power consumed in a circuit. Alright, here we have the simplest electric circuit, okay, where we have only the battery. Of course, we can also have the key, okay, here. And remember, from the battery, the current will flow, and we have a resistor here. Usually a conductor which has resistance, we call it a resistor, right? So let a current I, alright, a current I flows through a conductor of resistance R. So this is resistance R for time t, when the source of potential difference V is connected across its ends. So we have the potential difference V across the terminals of the battery. Now to find the electric energy supplied by the source. So how much will be the electric energy supplied by this battery, okay? Now we have to start from the definition of potential difference. Potential difference V is equal to work done W by charge Q, or V is equal to W by Q, and on cross multiplication we get W is equal to Q into V. We mark it as equation 3, right? Now from equation 2, which we have seen in the last slide, Q is equal to IT. So if you substitute for Q here by I into T, we have W is equal to V into I into T. V is already here. In place of Q, we will substitute I into T. So we get a relation W is equal to V I T. Hence, electrical energy, which is symbolized by W, is equal to Q into V. This is the one relation. Then is equal to V into I into T. This is another relation. So we can find out the electrical energy supplied by a source with the help of these two relations. Okay. Then we go to the electrical power. Electrical power P by definition is equal to energy supplied W divided by time T, okay, or symbolically we can write it as P is equal to W by T, okay. But what is W? W from the last slide we have seen it's equal to V into I into T, okay. Therefore, power, which is equal to W by T, can be written as V into I into T divided by T. So T and T will reduce. We will be left with V into I. We mark it as equation 5. Hence, electrical power P is equal to, first is equal to W by T. So W by T is equal to V into I. Okay, V into I. So with the help of these relations, we can find out how much is the electrical power of the source. Okay, thus power in watt is equal to potential difference in volt. This is potential difference in volt into current in ampere. Okay, into current in ampere. Okay, so the unit of power is watt. So if we take 1 watt, therefore is equal to 1 volt into 1 ampere. Okay, 1 watt is equal to 1 volt into 1 ampere. Please remember these relations. Okay, then we go to transmission of power from the power generating station to the consumer. How do we get the electrical power from the generating station to the household, okay, when we say to the consumer? Okay, please listen carefully here. There are steps that are important to be remembered. Okay, electric power is generated at the power generating stations, which are usually located very far from the areas where it is consumed. Very important point. Okay, we never get the generating power stations nearby. Rather, the generating power stations are usually very far from the point where it is consumed. Okay. Now, at the generating station, the electric power is generated at 11 kilovolt. When we say 11 kilovolt, it means this should be multiplied by 1000 to get it in volt. Okay, so it will be 11,000 in terms of volt. Okay, so that is how it is generated at the generating station. Now, the voltage of the power generated at the generating power station is first raised from 11 kilovolt to 132 kilovolt. Okay, so we have what is known as the grid station, and in the grid station, this voltage which is generated at the generating station is first raised. How do they raise it? By using step up transformer, alright, which you will learn in class 10. So it will be raised 12 times high. Okay, and why is it raised? The reason is this: to reduce loss of energy in transmission due to heating of line wires. Okay, to reduce loss of energy in transmission due to heating of line wires. Please listen carefully. If we transmit it at 11 kilovolt, there will be lots of energy which will be lost in the form of heat. Okay, because the line wires will be heated up, so that heat will be lost in the form of the loss of energy. Okay, and then it is transmitted to the grid substation. Okay, so from here it is transmitted to the grid substation. At the grid substation, its voltage is reduced from 132 kilovolt to 33 kilovolt before it is sent to the main station, where its voltage is further reduced to 11 kilovolt. So from the generating power station, which is raised to 132 kilovolt, it will first come to the grid substation. This grid substation will be reached by transmission through the high tension wires. Okay, and when the power reaches the grid substation, its voltage is reduced from 132 kilovolt to 33 kilovolt first. Why? Because big industries and big factories will need this voltage in order to operate the big machines. So it will first be reduced from here, where the big industries and the big factories will take this voltage. Okay, and then from the grid substation, it will be sent to the main substation, and at the main substation, its voltage will be reduced to 11 kilovolt. Why 11 kilovolt? Because small factories and small industries will need this voltage in order to operate their machines. Okay, then it will come to the city substation. So from the main substation, it will come to the city substation, where it is further reduced to 220 volts. Why 220 volts? because household voltage is 220 volts. Okay, so this is the generating power station. Okay, so we have the power station here. Okay, then from here it will be step up to 132 kilovolts. So over here it will be only 11 kilovolts. It will be generated only at 11 kilovolts. Then it will be transmitted into this station where it will be step up to 132 kilovolts. And with that, it will be sent through the high tension wires to the destination. Then it will be sent to this grid substation, okay, the grid substation, where it will be transmitted again, all right, to the main substation. Okay, but not high tension wires anymore. These are the line wires. Okay, and it will be at the main substation where it will be reduced to 33 kilovolts. So from here now, the big factories and the big industries will take it at 33 kilovolts. Okay, then from here it will come to the city substation where it will be reduced to first to 11 kilovolt. Okay, 11 kilovolt, where it will be taken for the small industries. Okay, so if you look at these steps, it will be much easier if you look with the help of these. Generating power station at 11 kilovolt. Then we have the grid substation at the generating power station where it will be step up to 132 kilovolts. Then it will come to the main substation where it will be stepped down to 33 kilovolts. Then it will come to the intermediate substation, which we call the intermediate substation, where it will be stepped down to 11 kilovolt. And from here now it will be stepped down further to 220 volts, where this will be supplied to the consumer. Supply of power to a house. To supply electric power to a house from the city substation, either the overhead wires or cables on poles or an underground cable is used. Please listen carefully to this. We have three types, okay, how the wires will come from the city substation to the house. And these three means depends upon the facilities available in different cities, okay, or in different towns. In some cities or towns, they have the overhead wires like what we have, okay, or some may have the cables on poles, okay, or some cities may have an underground cable instead of the overhead wires, okay. They have the wires underground, so we call it an underground cable, and from there they will take the connections, okay. So it will come in the form of a big cable. The cable has three wires inside it. One wire is known as the live or the phase wire with the symbol capital L. Another wire is the neutral wire, which is symbolized by capital N, and the third one is the earth wire, which is symbolized by capital E. Okay, now please listen carefully to this. The neutral and the earth wires are connected together at the local substation. Please listen, at the local substation, all right. The neutral and the earth wires are connected together. Why? so that the neutral and the earth wires are at the same potential, that is at 0 volt. These two should be at the same potential and they should be at 0 volt. So how to do it? They are connected together at the local substations at the low voltage. Okay. The live wire, also called the phase wire, is at 220 volts, meaning this is at a high potential. Okay. And it is the one that carries the current from the source to the distribution board. Distribution board is in the house just before the start of the household wiring. Okay, so from the point in the CT substation where current is to be taken, it operates at 220 volts. Okay, then it is the one that carries the current from that source. The source here is from these cables. Okay, and these that come from the city substation is referred to as the mains. Okay, the mains, not the main, the mains. So it's from the source, which is the mains, which will come to the distribution board. The neutral wire is for the return path of the current. Look at the functions of these three wires. The live wire carries the current, all right, from the source to the distribution board. The neutral wire is for the return path of the current. Okay, the return path of the current is through the neutral wire. Then the earth wire passes through the earth. So it is the one that has a connection to the earth. So we call it the earth wire. Okay. So that is how we get the supply of power to a house. Okay. We need to know the color coding of the line wires. When we say line wires, it means this cable that comes in with 3 wires. It's known as the line wire, this cable. Okay. We need to know the coding of the line wires. So how can we make out which is the live, which is the neutral, which is the earth? Here are the color coding for which by which we can make out. Okay. The live wire, it's either red or brown. So when you see the red wire or the brown wire, it means it's the live wire, the one that carries the current. Okay, and its voltage at the mains is 220 volts. And its purpose is to carry the current from the source to the appliance. When we say appliance, means anything that we connect in the circuit. All right. The neutral, how can we make out the neutral? Its color will be black or light blue. So when you see a black colored wire in a cable or light blue, it means it's the neutral wire. Okay, and it operates at 0 volt. And this is to provide the return path from appliance to the source. Okay, the remaining current will return back to the source through the neutral wire. Okay, then the earth wire. Earth is either green or yellow. Okay, when you see the green or the yellow, it means it's the earth wire, and it operates at 0 volt. It to provide connection to the earth. Its purpose or function is to provide connection to the earth. So from these colors, we will be able to make out which wire is for what purpose. Okay, and this is very important while making the connections in the household wiring. We need to know which is the live, which is the neutral, and which is the earth wire, because the connections will have to be done accordingly. Connection from pole to the distribution board. Okay, Now, to connect the cable from pole to the meter in a house, please remember this does not refer to the unit meter, alright? But this is a device. The meter in the house, it's a device. Hence, we spell it M-E-T-E-R, not M-E-T-R-E. That refers to the unit meter. Okay? To connect the cable from pole to the meter in a house, number one, first, a fuse of high rating equal to 50 ampere is connected in the live wire at the pole or just before the meter. Very important, okay? A fuse. We will be learning about a fuse later, but remember, a fuse of high rating, which is usually 50 ampere, is connected where in the live wire. So it's important to identify where is the live wire, because this fuse will come in the live wire. This will be connected either at the pole or just before the meter in a house. Okay, this fuse is called the company fuse or the pole fuse. Okay, it's called the company fuse or the pole fuse. Now, who will handle this fuse? Only the electric supply company staffs are authorized to handle it. Not you, not me, alright? Only the staffs from the company that supply electricity to us will handle this company fuse. Okay? Okay. The rating of the fuse depends on the load for which connection is taken from the company. Alright? Now please listen to this. If we need to have the connection for electricity in the house, we need to apply to the company that supply it. For us here, it is MEECL. So while applying, we need to mention how much is the total electric supply that we need in the house. Accordingly, they will fix the current rating of this fuse depending on it. For example, I want 10 kilowatts for the house, right, in total. So they will give us 50 ampere. But if it is 5, then they may give only 30 ampere. So depending on it, the rating of the fuse depends on the load for which connection is taken from the company, and in our case this company is MEECL. Okay, then after the company fuse, the cable is connected to an electric meter. So we have the meter which we mentioned here. All right, it will be connected to an electric meter, and this electric meter is mounted on the front wall or outside wall of the house. Just outside the house or on the front wall of the house. Okay, then from this meter, connections are made to the distribution board. Okay, from this meter, the connections are made to the distribution board, and before you reach the distribution board, there should be two things to be connected. Please listen. There has to be the main fuse and there has to be the main switch before we go to the distribution board. These are part of the distribution board. Okay, so before the wires go to the distribution board, we should connect the main fuse and the main switch. And how are they connected? Please listen to this carefully. The main fuse is connected to the live wire. Main fuse to the live wire only. Okay, but the main switch is connected to the live and the neutral wires. Why? Because when we switch off the main switch, both the live and the neutral wires should be disconnected. So that is the purpose of the main switch in the house. Okay, we want the connection through the live and the neutral wire to be broken. All right, so we make the connection of the main switch to both of them. All right, okay, the commercial unit of electrical energy. Electrical energy is generally measured in a unit called BOT, means Board of Trade units, or kilowatt hour, okay, or kilowatt hour. So what is 1 kilowatt hour? 1 kilowatt hour is defined as the amount of energy consumed when an electrical appliance of power 1 kilowatt is used for 1 hour. We have an appliance of 1 kilowatt used for 1 hour, then we call the energy kilowatt hour. Please remember, this is a unit of electrical energy, it's not the unit of electrical power, okay? The energy consumed in our houses, shops, factories is measured in kilowatt hour. So this is the unit, okay? Now, since power is equal to energy by time, so energy is equal to power into time. Just cross multiply. We get energy is equal to power into time. So if to calculate the energy in kilowatt hour, then energy in kilowatt hour should be equal to power in kilowatt into time in hour, okay? Power in kilowatt into time in hour. So we get 1 kilowatt hour is equal to 1 kilowatt into 1 hour. Now this is very important, and it gives us the relation between kilowatt hour with joule, okay? So you start from here. 1 kilowatt hour is equal to 1 kilowatt into 1 hour. And what is 1 kilowatt? It's 1000 watt. What is 1 hour? It's 60 into 60 seconds. We need to express it in terms of second because we want to get the relation with joule, okay? Now if we multiply, we will get 3600,000, and what is joule per second? And from here we get second. So second and second will reduce. So we will be getting the unit only in joule, okay? And if we write it in power notation, this will become 3.6 into 10 to the power 6 joule, okay? Hence, 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. Very important relationship. Okay, we go to electric meter. Please go through your textbook when it comes to electric meter. I cannot write all the details, okay? Electric meter, also called kilowatt hour meter, is a meter which measures the amount of electrical energy consumed by consumer in the unit kilowatt hour. The electricity bill is to be paid in this unit, okay? We pay the electricity bill in terms of kilowatt hour, okay? The main part of the meter is the armature A. It will be very difficult to explain. Armature is another subtopic, but it's not included in your course, so just take it for now, okay? It's the armature A, which is connected to the main line, okay? So inside an electric meter, we have the armature A, which is connected to the main line. So when any electrical appliance is put on, the electric current flows, all right? It flows through the meter. And when it flows through the meter, it flows through the armature. And when an armature receives the current, then it rotates, okay? So which rotates the armature. Then the counter fixed on the armature reads the number of oscillations. That means how many times it rotates, all right? Then this counter fixed on the armature will read the number of oscillations. Then 5 dials on the counter read the electricity consumption directly in kilowatt units. So we have 5 dials in the counter, all right, and these will read the electricity consumption in kilowatt units, okay? Now nowadays the old meters are replaced by electronic meters, right? Okay, so that is about an electric meter in short. Please go through your textbook to get more in depth about an electric meter. Then we go to electric fuse. Please learn electric fuse very, very carefully because you will be using it again in class 10. The electric fuse is a safety device, very important word, alright, safety device, this one, which limits the current in the electric circuit. How is it a safety device? Because it limits the current in the electric circuit. Alright, I'll give you an example. Suppose we use an electric fuse of 5 ampere current carrying capacity, okay? The current more than 5 ampere can come into the circuit, but when it comes to the fuse, only 5 ampere will pass through it because the current carrying capacity is only 5 ampere. Get it? As a result, it limits the current that comes into the circuit only to 5 ampere, even though higher current comes in the circuit. But to this particular path, only 5 ampere will pass. So it limits the current, okay? Alright. Secondly, why is it a safety device? Because it safeguards the circuit and the appliances connected in the circuit from being damaged due to overheating from short circuiting or voltage fluctuation. Okay, please listen to this. It safeguards the circuit and the appliances connected in this particular connection where we have the electric fuse, okay? Usually before any appliance or the circuit, we have the electric fuse. Now, how does it safeguard? Here is how it safeguards. As I had given you an example just now, suppose we have a fuse of 5 ampere. Now, current of 10 amperes come into the circuit. So, when current more than 5 amperes passes through this circuit, then the electric fuse, because of excess current, will be overheated. Alright, and this excess current can come because of short circuiting or there is a voltage fluctuation. So when it gets overheating, it melts itself, and when it melts, it breaks the circuit. There is a break in the circuit, so no more current will pass into the circuit or into the appliance, and that's how it safeguards the circuit and the appliances, okay? Now, a fuse wire. In the electric fuse, we have a fuse wire, okay? A fuse, it consists of a fuse wire F, which is stretched between the two terminals T1 and T2 in a porcelain holder. The holder fits into the porcelain holder, alright? The purpose of a fuse. The fuse should always be connected to the live wire. Extremely important. The fuse should always be connected to the live wire. Figure A, so this is figure A, shows a fuse in the live wire. So here is a fuse in the live wire. Okay, right. When there is a short circuit, okay, because of some fault, there is a short circuit. So when there is a short circuit, excess current will pass. So this wire gets heated up. This fuse wire gets heated up to the extent that it melts. When it melts, a gap is produced in the live wire and the circuit becomes incomplete or breaks. Now look at figure B. This wire breaks because it melts, okay? It melts because of being overheated. So there is a gap here, there is a break here. Whenever there is a break in the circuit, no more current will pass because this circuit becomes incomplete. Current will pass only when there is a complete circuit, there is no break anywhere. Alright, so no current then flows into the appliance, and the appliance or the circuit is saved because no more current passes. Okay, then after removing the fault in the circuit or the appliance, a new fuse wire is fixed between the terminals T1 and T2 in the holder to complete the circuit again. Okay, remove the default first. Alright, and then take a new fuse wire, connect it here, then the circuit will become complete, and when the circuit is complete, then current will pass through it again. Alright. Now nowadays the new gadgets are provided with cartridge type fuse. There is a fuse which is already provided with the costly gadgets nowadays, which we call the cartridge type fuse.